Hey guys, welcome back to another 3D printing video. And in this video, we're going to be checking out the Weedo X40 IDEX printer, which stands for Independent Dual Extruder. So I'm really excited to see what this printer can do. So in this video, we're going to unbox it, set it up, and do some prints. All right, so let's get started. Alright guys, so the printer comes in this box and it's very large. We got two straps going around it, the logo here on one of the sides. So here we can see some of the specs, the name, the weight, 11 kilograms. That's without packaging, and with the packaging, 17.5. So pretty heavy printer and pretty large packaging with the dimensions here in centimeters. So let's go ahead and open this thing up. I'm gonna cut these straps off. And here we have some stickers that say precision instrument inside, please handle carefully. So that's nice that they put that there for the shipping people. Not that those shipping guys really care too much, but surprisingly my box arrived in great condition. All right, let's open this thing up. So on the very top layer, we got a nice thick cardboard. And this is what we see. So it looks like the base is on the top and the gantry is underneath that. So we get some documentation. It's like package contents, assembly. It looks quite simple actually. And then how to get started. And here we have another little guide to connect the printer to the internet if you wanted to do that. So right off the bat, guys, I'm noticing there's quite a bit of air on each side here. And they got these fillers. So they did oversize the box a bit to keep the printer safe. So here we have the build plate. Let's pull that off real quick. Take a quick look at it. Wow, this thing is heavy. It does have a little flex to it, but not very much. But I think it's enough to get larger items off. Smaller items will definitely not flex very easily. But yeah, it looks like we just have a piece of steel on the back of it. And then we got a build sticker on top of the steel. So very interesting. No branding, just clean black. And it is secured by these little clips here. And we'll take a closer look at all this in a little bit. So I'm going to go ahead and pull the base out. It has got a really good weight to it, quite heavy and quite an interesting design. Very unique. So we got more foam, and below that we have the gantry, and it does appear to be all pre-assembled. And you guys can see the dual hot ends right here, and they do operate separately. As you can see, there's dual belts here. We do have one induction sensor here on this side, and that's what it looks like from the back. And we do get dual Z-axis motors, but unfortunately the rods are not tethered together on the top. So we'll see how well this printer does with staying level. And so on the very bottom, looks like we have some boxes. Spool of filament, looks like PLA in a red color. Another spool. Looks like also PLA maybe. They're not labeled, not even on the box. But yeah, it's nice that they included little spools here to do a trial test. So these are just spacers. And then we got another box here that's quite large. And it has all of our accessories in here. And we'll take a closer look at this in a second. And so that looks like everything for the box. Packed very well. I've noticed they're using the white foam strategically. A lot of it's cut out and to shape, so that minimizes on the waste. So that's nice to see. So overall, very well packed. So here we are looking at the base, and the first thing I want to do is I want to flip it around and check out the electronics underneath. But before we do that, let's remove this bed and then flip the printer around. And here underneath we can see there's a cover and 8 bolts holding it. But we will need an Allen wrench, so let's go to this box here and go over quickly what's in here. So it appears we get a little camera, and there's some bolts in here too. A USB cable to connect from the printer to the computer. A spatula that's not sharpened. A US type power cord. Looks like pieces to a spool holder. We got the frame and the 2 round pipes. A couple T-brackets for reinforcing the frame. A baggie of little bolts, a glue stick, and a knife. And the last part here is we have a baggie of tools. We have an extra end stop switch and an SD card in there, a USB SD card reader, some zip ties, and our tools. So we get 2 open-ended wrenches and a pack of Allen wrenches. All right, so let's grab the one we need and take out these little bolts. So this lid should just come right off. So let's take a closer look at what we got here. So everything looks very well organized, and interestingly enough, just enough space to fit everything you need. So we got a power supply, 480 watts, 24 volts. All the wiring seems to be crimped and well organized. Here we have a switch mechanism, and I'm guessing that's for this power switch here. Our touchscreen board, and the main board that controls everything. So it looks like our stepper motors are synced, but they are not removable. And this is the name of the board, 3DR73 by Red Bank. And we do have a 32-bit ARM processor, a cooling fan to cool the board off. So yeah, overall very nice and clean execution here, and quite interesting layout with everything being up front and the rest of the frame is just open. So I'm going to put the lid back on and we'll start with the assembly. So the assembly process should be quite simple. We're just going to set the gantry onto the base, and there's 2 bolts on each side that secure it. And then step 2, we're going to use the side braces to reinforce it. Step 3, install the spool holders, and step 4, the web camera. And that's all the steps. So assembling this thing should be quite simple. So first thing we need to do is cut off these zip ties, and that's going to release all of our cables here. I'm going to lay them to the side. Our gantry will simply just sit right here and then bolt from underneath. So in the back of where the camera is, which is quite interesting that it comes with one, there are 4 bolts. Let's go ahead and set the gantry over it. So just like that, we're going to line it up. Now on this printer, it's quite simple to get under here. The only issue is there is some wires running under here, so we're going to have to be careful with that. But yeah, I'm just going to take a bolt and then go through the channel, and then I'm going to line it up and tighten it in there. So you can easily stick your hand in there and start it by hand. So that part is quite nice and convenient. We're going to grab our biggest Allen wrench. All right, so I'm not going to tighten this yet. Let's flip the printer to the other side, and we're going to put our other 2 bolts through here. Again, there's a bunch of wires here. They're technically not in the way, but yeah, we're just going to line it up and start the bolt. And so we can go ahead and snug these up really good, and you want to go, you know, pretty tight. All right, so that feels good. So I'm going to go back and tighten the other side, and then we'll install these T-plates. So our T-plates go right here on each side of the printer. There is a baggie of bolts that a bolt goes through here, and then you put a T-nut on the other side, and then you lock it into the channel. But the unfortunate part is that my printer only came with bolts and no T-nuts. Because I need 8 of them, I don't think I can scavenge that many. And what makes that even worse is that the spool holders also need T-nuts, because that's how they mount. So I need at least 4 for that for sure. So unfortunately, I'm not going to be installing my strengthening plates here because I don't have T-nuts. So I guess these things happen, but I'm going to try to find 4 at least for the spool holders, and we'll install those. All right, so I found 4 T-nuts. Let's grab 4 bolts. And so what we need to do is put the bolt through the top and then put a T-nut on it, just like that. And there's 2 of them. So now we're going to go to the top, looking at the back of the printer. So the back's coming this way. We're going to install these leaning to the back. And so the T-nuts will simply just go into the channel. And we're going to install this where our tube is about the middle of where the extruder is. And I'll show you guys a little closer what I'm talking about in a second. Let's go ahead and install the other one also. Now we're going to take the tube part. And by the way, these are metal and they have plastic nuts on them. So the side that has the 2 nuts, we're going to unscrew one of them, put the holder through the bracket, and tighten the nut on the other end. Quite a simple procedure. Same thing for this side. And that's it, the spool holders are on. So we can see how the spool holders mount right on top of the channel. T-nuts lock it in. And so what you want to do, and it's almost pretty much flush here, but you want the center of this to match about the center of where the filament is going to go into, the filament detector. But yeah, anything close should be good enough. All right, so for our last step, we're going to be installing this little cam here. It's going to go on the right side of the printer, and there's a plug. So we're going to plug that in. So there is a T-nut that's going to go into the channel, and then we're going to take our wrench, we're going to loosen the T-nut, and then tighten it back up to lock it in. And that's it, our camera is on. And so for the last step, we just have to plug in a few things, which is all here in the back. So we got a couple wires here going to the Z-axis motors. And then we just have a main ribbon cable that plugs into the junction box right here. So they made it really simple with the wiring. Same thing on this other side, stepper motor and the ribbon cable. And that's it, that's all the wiring. And so yeah, we're pretty much finished with the installation process. So I'm gonna go ahead and cut these zip ties. Now our extruders can move independently. and you guys can see how that works. We got little clean out brushes there on the side. Now there is another step that's quite important that we forgot to do, is check all the rollers. And on the bed, normally I like to do that before I installed the gantry, but I didn't do it, so we need to do it now. So this printer has 3 rollers on each side on the outside of these 2 channels. So one of the sides has an eccentric nut adjustability and the other side is just stationary. And you guys can see the 3 rollers with the eccentric nuts on them. Now on mine, the rollers are really greasy. The best way to do this is to spin the roller until it has a little bit of friction, and that's what you want on all the rollers. So you want everything to be tight enough where it doesn't wobble, but loose enough where it's really spinning easy. So if we look at mine, you can see that the middle roller doesn't always roll, so it must be too loose, and the outer one seems to be rolling. So I'm going to grab this wrench, go in there, and I'm going to spin it where I need it to make it looser or tighter. And so with the 3 rollers, the best way I found to adjust them is make one really loose and then adjust the 2. Then once you get these 2 good, then adjust the 3rd one, and that makes them all run really even on the channel, and they're all spinning, as you guys can see. And most importantly, when you move this back and forth, you want it to be really smooth. No jitteriness or any kind of catching on anything. Just a smooth motion. If you have any kind of jitteriness, you might be too tight. And also you want to check these rollers, and the adjustable ones are on the inside. So you just want to make sure that these are tight enough, because with this printer having dual Z axes, everything is controlled quite well. And on the X axis, obviously we don't have to do anything there because we have a linear rail that runs both of the hot ends. Now one thing I am noticing is one of the belts is definitely too loose. So this one down here is perfect, but the one on the top here, which is part of this one here, is a little loose, so we need to tighten that up. So we're looking at the back of the printer and looking at all the pulleys and all the gears that this belt goes through. I don't really see an obvious place to tighten it. So I think the easiest and fastest thing to do is take off one of the sides and then jump a tooth and then put it back on. So I'm going to go ahead and take this side off here. There's just a little bolt that the belt loops around. You can kind of see that right there. So we're going to cut off the little zip ties. So all we're going to do is just go forward 1 bolt, so that should tighten it up about what we need. Put on the zip tie and start the bolt, and then we'll check the tightness. Oh yeah, that feels perfect. It's actually just like the other one. All right, so that's good right there. I'm going to go ahead and put another zip tie to permanently secure it. Also check your Y belt, make sure it's tight enough. Mine feels a little bit tight, honestly. There's a motor right here with 4 bolts, and it looks like it does adjust. All right, we're going to move the motor just a little bit forward, and that's much better right there. So it's still tight, still play music on it, but it's not ridiculously tight like it was earlier. And that's it. Now the other thing that's probably a good idea to do is go around and check all the main frame bolts, because over time these things loosen. So it's a good idea to go back and just kind of snug everything up. So let's go ahead and put our build platform back on, and it simply secures with these little clips here that are permanently mounted. And that's pretty much it. We are assembled. Now there's one more thing that you absolutely want to do before you do anything else, and that is check the voltage. The voltage switch can be accessed from the back. So mine's already switched to 115, so I'm good to go. So depending on where you live, you want to check, make sure it's switched to the right position. All right, so let's take a closer look at this printer. So on the top we have the 2 spool holders, and they are all metal. We have dual Z-axis rods, but they're not tethered. But I wish they were tethered, because sometimes that can give you some issues with trying to keep it level. So we have dual extrusions, and they are independent from each other. So both of the heads completely operate on their own motors, and they're not shared. And you guys can see when I move one, the other one doesn't move. So this is why we see all these belts. So this is great for printing 2 separate things at the same time. So we are using a linear rail for the X-axis. We have an induction type sensor here for the Z-axis. It is a Bowden tube style design, so we have extruders separately here with PTFE tubings. Now on the extruders, I'm not too sure how all this is going to survive the test of time, because it's all plastic, and not only that, it's 3D printed. Or at least this piece is, but this piece here looks like it's injected molded. So it's a mix of parts. It feels actually pretty good and smooth. So now one issue that I definitely see is these filament detectors, and they have plastic inserts, and our filament does come from the top. So we're gonna have strain constantly on this plastic, and I have a feeling it's gonna wear in really quick. We'll just have to see how that holds up. So we do have a main junction box where our main cable comes in and then distributes everything out of there into all the components. And all the stepper motors are this type here. We do have a semi-flexible coupler here that connects to our Z-axis motor. And there are 2 of everything on this printer. So here we can see the hot ends. The heat block is insulated. Heat break fan is inside, and the parts cooling fan is on the outside of the housing. And that's the fan you see there, with a 3D printed duct pointing at the nozzle. We have a very large build area, 300 by 300 by 400. And what's great is the bed insulated, so that should help with heating. And this is what our springs and knobs look like. They're on the smaller side, but definitely reasonable enough to turn. And the reason they're small is because they need clearance to travel back and forth. I definitely like the use of this wide double channel for the y-axis. That should make it quite stable, especially with 3 rollers on each side. And you guys saw already, this is our y-axis motor here with our y-axis end-stop switch. The whole printer is sitting pretty tall off the table, you can see, and there are rubber feet on all 4 corners of the printer. So back up front, we can see we have brushes to clean out the nozzles as they travel over here. There's not only brushes, but you can see little flaps that make sure that the nozzle is really clean before it goes back to printing. Pretty interesting. We'll see how that works. So even though each extruder is independent, they both have their own end stops here at the end. And there's a switch here and another one here. So as we come down to the front, we have the camera, and it is in a 3D printed housing, and the lens is pointing kind of up towards the bed, and that gives it the ability to see what's on the bed and higher. Right next to the camera we have a QR code, and that brings us to the front of the printer, which looks really nice. Got the logo here, large touchscreen, and a push power button. So going to the right side, this is where our micro SD card goes, and what's interesting is there's one in there already, and also our USB port to connect to the computer. And to the left side we have a sticker and also a fused AC port with an on and off switch. So yeah, quite an interesting looking printer, and it is quite a large size and takes up quite a bit of room on the table and also going up. So for the next part, let's power the printer on. Hit the switch here on the side, and I can hear some fans that come on the bottom. Now that's a little strange, and the reason for that is because I haven't even pushed the power button here on the front, so the screen's even off. I'm not sure why they would do that. Normally with this setup, everything is off until engage it here in the front. In any case, let's go ahead and push this button, and we can see it glows blue, and we got a boot up. So I think the first thing we need to do is see if all of our axes work. So let's go to maintenance, and here we can see we got filament feed, filament retract, preheat. Click on next, jog mode, bed level, and Z offset. Proximity height, nozzle offset, and motor off. So I think we need jog mode here, so we can move all of the axes individually, or we got a hot button here to return home, so I'm gonna do that. Alright, so this extruder is moving, the other one's moving, the y-axis is moving, and now the Z is moving. And we're going to see if our leveling sensor there works. And sure enough, it does. Alright, well that's a good sign. So next, let's go to preheat, and we're going to heat up everything, both of the nozzles and the bed. And so here it's set on all the temperatures, and the bed is on 80. It's definitely too high. I'm going to turn it down to 60. And we'll push OK here, and it's going to start the preheating process. And there's a cool little graph here that shows the progress. So it looks like everything is working, and the nozzles are preheating very reasonably quick, and the bed obviously is going to take a little bit longer because it's quite large, but it should do pretty well because it is insulated. So I can say right away that the nozzles heat up super fast. It hasn't even been a minute and they're already full temperature. And now that there's more power allocated, I think the bed will start going quicker. So it's definitely reasonably quick. So as everything's preheating, the next thing we need to do is level our bed. Now before we do any kind of adjustments, what we need to do first, since we have a dual Z-axis extruder, we need to make sure that we're offset correctly on both ends. And so what we're going to do is we're just going to simply measure from the frame to the bottom of, let's say, this bracket here. As long as we do it the same on each side, we can get a level plane. So you can use a tape measure or anything you have just to measure the distance. And all we're doing is just making it equal on this side and that side. It doesn't matter how high or how tall. We're leveling out the x-axis plane to the frame. So I'm just going to use a couple of calibration cubes to gauge mine. All right. And then go to the other side and do this one. So this one's a lot higher than the other one. That was already offset quite a bit. All right. Measure this one again. And that's the same like the other one. All right. So now that we know that plane is level, we can go to bed leveling, and it has a little walkthrough to level the bed. So it looks like we're going to start with the four corners. So let's click begin. So you are going to need some kind of paper. I'm just going to use a Post-it note. Not sure what it's doing now. It's completely going up for some reason. Okay, I think I'm gonna have to turn it off because it's going way too high. Yeah, I think it's got its axes mixed up, so it's moving all the way up. And I had to turn it off right before it got here because it was about to crash into that. Well, that's not good. So I guess this printer probably needs a firmware update to fix that problem. So I'm gonna send it back home and we'll just have to level the bed manually for now. So since we're gonna have to level it manually, let's go ahead and turn the motors off. That way we can move it around and we'll just go to every corner. So I can already see that this was way too high here. So yeah, we're just gonna do a normal old school style bed leveling. And hopefully you won't have this issue because this thing does have out of bed leveling, so where it measures the bed, and obviously we cannot access that at the moment. All right, so I got it as level as possible. Let's go ahead and home it again. That looks about right where the nozzle is, so I think we're pretty close. Now we do have a Z offset, so let's try to use that and see if that works. All right, so it's doing something interesting. Oh, look at that. Well, I guess we found our out of bed leveling by accident. So I just clicked on Z axis offset and this is what it's doing. Very weird. Okay, well that's good news. So adjust it up and down incrementally. So right now it's a little bit too low, so I'm gonna go up just a little bit. Okay, it was set at minus 0.3. So I think I'm gonna set it at minus 0.20. It seems to be better. All right, so we're gonna click save. I was worried about it going up too high. So I'm gonna click on maintenance and filament feed. We're gonna click on PLA and it's gonna ask us which nozzle, left or right. I guess we're gonna choose left. And now it's preheating this nozzle. So let's go ahead and open up the filament that was included. So we got a roll of white, another roll of red. So I'm gonna use red on the left side. And you guys saw how I touched it and it dropped. So right now we actually knocked off our Z-axis, meaning one is higher than the other, or it's not level again. So everything we did earlier was compromised just because, you know, you barely touch it and it falls. So this is why I always say that the Z rods need to be tethered. There's no other good way to do it unless you tether it. So it looks like we're hot enough and seepage coming out. Let's go ahead and do the other side. I'm gonna go ahead and hang it here, bring it into the extruder. So the good part is the extruders feed in really easy back here. Surprisingly, that's usually you have to fight with it. All right, and this one's through too. Now since we bumped off the axes, we need to home the printer again and re-level them. And this is going to be a common occurrence because you guys can see that whenever it releases the motors, it just drops really easily. And so it's always going to be at the wrong level if you even slightly touch it. Now, one important thing that I actually totally forgot to do, we do have two hot ends, is checking this one, how it is offset the bed here to the other one, make sure they're the same level. So I guess we do need to check that also. So if you're gonna have this printer, you wanna find something that you can constantly use to gauge it before you start printing. All right, so that looks good. I'm gonna go back and I'm going to motor off it. Being very careful, I'm gonna push this over without pushing it down any. We're gonna move this over straight to the other one and see what our offset looks like. And thankfully, it looks really, really close just by looking at it. They actually appear to be the same exactly. So that is a plus. So yeah, everything looks good. And so I think we're ready to start our first print. So let's click on the print here. And here we have two options, Wi-Fi or the SD card. So we're gonna click on SD card. So it does look like we have some G codes here. So I do see dual color and some other stuff. Well, let's just go ahead and click on this 20 G code. I'm guessing it's going to just make a box. So let's see what that looks like. So I'm gonna choose that. And so it gives us a little preview of what it's going to print and some parameters, including the time it's going to take, which is 11 minutes. So let's go ahead and do that. So I'm going to click print and it's going to initiate it. All right, so let's see how this goes. So it's taking measurements again. Interesting. So every time it prints, I guess it takes a measurement. Well, that's pretty smart because I guess they know you're going to bump it off quite often. Very interesting. And there it goes. All right, and it appears to be that we're perfectly offset from the bed also. So it looks like that one worked out pretty good. And it looks like it is building a raft. The printer is very, very quiet. So I'm gonna bring my microphone in. There's practically no sound coming out of that thing. The fans are reasonably quiet, and the stepper motors are ultra quiet. So I'm very happy to report that this printer is silent, and that's quite refreshing and definitely a more pleasant experience. So let's take a closer look at the UI. So here we have the image that it's printing, the file name, the temperature on the hot end, and it looks like they're both heated for some reason. The bed temperature, I guess they did not initiate the heated bed on this print. The time that passed and the time that's left. So that's a really nice feature there. This is our progress bar, 52% done. Then we have some hot buttons, quit, pause, and settings. So if we click on settings, we get more control. We can change our filament, temperature control, speed control. Well, let's go to temperature. So the bed was not set to anything. I guess let's go to 50 for fun here. Let's turn off the right nozzle completely. Okay, speed. So here we can increase or decrease the speed of the printer, and it kind of gives you just hot buttons. So we got auto power off, so once the printer's done printing, it's going to turn itself off. But I'm not sure if that's going to completely turn everything off, because whenever it was off, there were still some fans on underneath. So I'm not sure how useful this feature will be. And then we got run out sensors, which are off for some reason by default. And I guess we can turn those on the next time around and see how that works. So pretty straightforward, some basic controls. So this is a pretty short print, and it's actually almost finished. So we're literally taking only 11 minutes. So it's pretty impressive for 11 minutes to be finished already with that size of a print. Not very big, but it's still very quick. Oh wow, look at that. It's actually finished 1 minute early. It's been only 10 minutes. All right, so it's very, very slowly presenting itself to the front. That might be a little too slow. Okay. All right, this printer is quite interesting in what it decides to do. All right, well, let's see if we can pop it off. So this is a pretty small print, and the bed is still warm, but I'm kind of curious. Let's see if we can take it off. And by the way, the printer just auto shut off. Not really the correct way, because the fans still are running underneath, so only the display turned off. But our power supply seems to be running. That's what that sound is. So yeah, you probably don't need to take off this steel plate normally for smaller prints, but yeah, there's definitely not enough flux here to use it on smaller prints. Now for a really large one, this will definitely come in use because you can flex it a bit. So we need to wait a little bit till it cools off, and we can pop it off. But you guys can see here how a screen went black. So if we push it again, it'll reboot it. So this is kind of good if the power supply was working with it, but it seems like the way it's set up, the power supply just keeps running, or at least the fan. So I'm not sure how useful this would be. So let's go over the UI really quick. So we got the hot end temperatures on both left and right. The bed temperature, the Wi-Fi setting is off right now. This is where we print our files. This is where we set up stuff like Wi-Fi. So if we click that, we can connect it. Language setting. There's the languages available, and then we got machine info, some things about the printer and the firmware version. Next here, so here we can choose to power on and off automatically. Run out sensors, so might as well turn that on. So here we have a post option, and I think this is to postpone a print to a certain time. Power and save mode, it'll turn off after 15 minutes. Here's where we can update it, and also we have parameters. So this just shows us the home offsets, the Z probes, and the stepper motor current. So let's go to maintenance. This is where we're going to feed the filament, retract the filament, preheat the machine, move it, including home is here. The bed leveling, which didn't work for us, but the Z offset did. Proximity height, and then we got the offset between the two nozzles. So once we start doing color print, if we have issues with the colors not lining up, because we do have two separate nozzles printing the same model in two different materials or colors, you could have an offset that you would need to adjust here. So, and then we got our motor off button here that releases the stepper motors. So yeah, pretty simple and quite intuitive UI. And here we just have a help button, and it can do some self-diagnostics, wiki, and contact. So alright, so let's grab our print off the bed and take a look at it. It's not coming off very easy, and the included spatula is not sharpened. So yeah, this thing's stuck on there pretty well. So I do have another spatula that's a little bit more sharpened. I think that will help. You just got to be careful with these spatulas because you can hurt yourself. Yeah, interestingly enough, that stuck better to the bed than I thought it would. Okay, so that just flew off the raft. So I'm not sure exactly what this is, but just looking at the print quality, it's very, very good. All right, well, that's good. So we know our printer works. So let's print another test file. So I'm going to go into print, SD card. Let's go ahead and do this dual 2 test G-code. So we should use both of our nozzles. Okay, so it's like a multi-layered kind of print. PLA. So it's only going to take 14 minutes to do this one. All right, let's go for it. All right, there it goes. That's building a raft. We'll see how this print does because it is a multicolor print. Also guys, I noticed that the nozzles, they purge here on the side before they print, and then they clean themselves out on these brushes, which is really nice. So before it even starts printing, the filament is already purged and then cleaned off on the brush. So we should be switching over to the other color here shortly. We're at 23%. So it is building a, okay, there it goes, switching the nozzles. Looks like it's waiting maybe to, okay, it's purging actually. You can see it purging. And there it goes, look at that. Right off the bat, the color change is very nice because I don't see any kind of oozing or anything weird. And we are building a wall around the model as a purge, I guess. Well, that's quite interesting. I think this printer is going to do quite well in this area. Brushes and the technique it has, and it purges before it goes. Seems to be very impressive. And now looking at it, I can definitely see that there's a problem already. There is a shift in the color. So the colors are not lighting up, or the two nozzles are not printing at exactly the same spot. And we'll take a closer look at that, and we'll have to adjust that. All right, so it's finished. And again, it's sticking really good, surprisingly. I might have to adjust the offset a little bit, because if I'm having this much trouble with small items, see if I can just scrape it down like this. There we go. Yeah, it seems to stick a little too well. And that's definitely a better problem to have than not sticking. But in any case, so yeah, you guys can see how we are offset on the two colors. So it looks like they need to align closer together in order to match up. Gotta remember where it was, I think in maintenance. Yep, nozzle offset. So we got coarse tune, fine tune, and then Z-axis offset. But looking at our print, I don't really think we need to do any kind of Z-axis offset. Pretty much perfect because it's sitting really nice. So let's do coarse tune. So here it says print the file called nozzle coarse tune.g code. Select a number on the blocks. Okay, so I guess we need to print something out first, and then we can choose the number, which one matches up the best. Let's see if we have that file. We're gonna go to print, TF card. Okay, here we go. Nozzle coarse tune. Well, let's go ahead and print that. Click print, and then we'll adjust our parameters according to this model that it's about to print. Well, that's a pretty interesting way of fine-tuning it. So we'll be back once it's done. All right, and our gauge is finished, and on the top of it we can see it says 1, 2, 3, 4, 5. So what we're supposed to do is we're supposed to look at these and see which one matches up the best, and looks like number 2 here matches really good. It has the least offset compared to the rest of them, but it's still not perfect, so I think we're gonna have to do a fine tune after that. Nozzle offset, and then coarse tune, and then we'll choose number 2 and save it. And that should get us a lot closer to where we need to be. But let's go ahead and go to the fine tune. So here it says we need to print the fine tune file. So here we see the fine tune G code. So let's go ahead and print that. I'm really happy that they took the time to make this really easy for the end user to really match up everything. All right, so we printed the fine tuner, and quite a bit to look at. There's all the way to 10. And so this one actually offsets both ways. And looking at them a bit closer, I think number 6 is my best bet. It's very, very close to where it needs to be. 6 is perfect enough for us. So I'm gonna choose 6, and we should be good. Click next. So actually it asks you for 2 numbers. So it asks you for the, let me just cancel it over. So this is for the X and Y. So the first one is the X axis. I guess that's what horizontal means. So, and that's definitely 6. So once we choose that, and next it goes to the vertical. So that means the Y, I'm guessing. And for the Y, I would choose the 5, which is actually 0. And that was my initial impression from our first print that we made, that we had no offset on the Y, only the X. All right, well that's cool. So we're gonna save it, and we're done. So now we should get a perfect color print every time. So let's go and print something. I guess let's print the same thing we did earlier, and we'll see how good this one turns out. All right, and so our little test is done, and it looks pretty good. So this just popped off. So yeah, looking at it here up close, it's not too bad, but for some reason it's still not perfect. I can see that the Y is kind of shifted a bit. Well, that's odd. So our X is very good, but our Y, I would say it's not perfect. So I'm gonna try to play around with the settings a bit more, because on our first print the Y was perfect and the X was shifted. So maybe I didn't do something right completely in aligning them, or maybe I got these backwards. So let me put this to 0 next, and then this to 1, and I'm gonna try to print it again. So after printing a few more of these little test blocks, I finally tuned it in, and let me show you guys the parameters that I used. So on the first one, it's still on 5, which is 0. And on the vertical, it's 3, so minus 0.2. And that turned out to be perfect for me. So I'm going to print out a few models, including color ones, and we'll see how those turn out. Actually, guys, let's jump to the computer real quick. We can check out the slicer. Just want to give a quick brief overview of how to do the dual color. So when you install the program into your computer, and it should be on the SD card, and this is what it will be prompted with. So you're going to go down to Weedo here, check the X40, and then add. So I already added it, you can see here. So Cura is pretty simple to use. Let's go ahead and drag a dual color print into the slicer. So I'm going to grab both of the models together and drop them in. So this is the calibration cube, and you guys can see that they're in 2 separate pieces. So the first thing you want to do is select the secondary piece and then right click and choose the right extruder. And that's going to give it a different color. So now the printer will know which is which, and this is going to be our 2 colors. Now as you can see, they're separated, so we need to combine them. So we're going to select the first one, click shift and select the other one. And now that they're both selected, right click and then go down here to merge models. And once we click that, it's going to combine them, and now you can do whatever you want with it, scale it, move it around, just like a normal model. And so one thing that's kind of important is right here in the slicer, if you look, we have extruder 1 and then extruder 2. So if you change something on extruder 1, not everything changes in extruder 2. So you need to go in there and check, make sure, everything lines up how you want it, because they are separate extruders. It needs to be changed on both. So the parameters I didn't really mess with too much. I just changed the wall line to 3, then top layer 6, bottom 5. Retraction I left the way it was, which is 4.5, and that seemed to be good. Printed everything in 50 millimeters per second. Mostly used skirt. A few times used the raft by accident. And here we have spiralized mode, which is under special modes. And to find that, you're just going to click on this little gear. And here you have a huge list of different options you can choose. So this is definitely for more advanced users, but that's what you will find. The special modes is just click on any gear and it will take you to all the modes that Cura has. So yeah, it's pretty simple. Once you get all your parameters in on both nozzles, then you're going to just click the slice and it's going to produce that G-code. And you take the G-code to the printer and start printing. Alright, so I printed a couple color models and they seem to turn out pretty good. So I got a little calibration cube and a squirtle. So let's look at the cube first. So when you do dual color printing, it builds like this little wall around it. It's really thin, one layer. And it usually covers up the print. But right off the bat, it looks really good. Now, the first thing I am noticing is we do have some under extrusion. I don't know if you guys can see or not, but on the white. So it looks like we have maybe a little bit of snagging going on or something. But the blue actually did really good. There's no issues really. Now we can see some ghosting there. Maybe you guys can see. But overall looks really solid. This might be the cleanest color print I ever seen, at least from a setup like this. The top looks great also, and the bottom is good too. So I think for the next part I'm going to put in the silky black that I usually do, and we're going to print a calibration cube with that so we can really see what we're looking at. Well, let's go ahead and look at this squirtle, silver and white, and you guys can see how it's encased. But it should be quite easy. We should just push it out. Well, I guess we'll have to break them apart. All right. So here we have silver and white, and just looking at it overall, it looks pretty good. Now we did have a pretty serious issue there on the white. For some reason, it completely split up over there on the back. I'm not sure why that happened. But if we look at the transition between the 2 colors, and that's what's important here, that's actually really nice. So as far as the color change between the 2 colors and how they sit together, this printer does very well, and probably this is the best I've ever seen. This is definitely much better and actually very presentable of how it puts them together. So we can see on the shiny parts of the silver how the layers are sitting, which are pretty good. So overall, seems like this printer is delivering very nice print quality. Now we do have some overhangs here that are kind of droopy, but I think that just needs a little better cooling maybe. Alright, well I'm pretty excited to print more color prints, but before I do that, I'm going to print a calibration cube and a benchy in the silk black. Alright, so we got the calibration cube and the benchy, and let's start with this cube. And I have to say guys, I'm quite impressed with this printer. Now there is some vibrations, you can see here's our X and some ghosting, and the Y has more ghosting and also just a little bit of vibrations, but not bad honestly. So here's our X wall and our Y wall. The top, beautiful, and the bottom, pretty good. And also importantly, the corners are nice and sharp and there's nothing weird going on. So yeah, layers are going down really nice. So let's look at the benchy. This is going to tell us a lot more. So right away you can see on the bottom there the reflections. The layers are really sitting good. And here on the flat surface we do have a little bit of vibrations here and some ghosting, looks like. Very minor, but you guys can see the ghosting right there. And the front here is nice and straight. So yeah, pretty darn good. So very solid print, and it looks like we don't have any kind of stringing or anything too weird going on. So again, on the walls we can see there's quite a bit of ghosting going on. Not the end of the world, but it is there. And our overhangs look pretty good on this benchy, even here on these arches. So very impressive for this printer. So not only can it do the colors extremely well, it puts the layers down really good, and that's just going to enhance the whole multi-material color printing. So I'm going to try to print a few larger prints that are color, and we'll check out what those look like. So I just completed another dual color print and just wanted to show you guys how much purging that these nozzles do on the side and all of the, I guess, mess that it creates. So I've only printed like 3 models, and we definitely have quite a bit of extra waste, and that's not even including the barrier that it prints around. Of course, that's really thin and probably also almost nothing. Yeah, it seems like clean out is a little bit extreme and should be cut about in half, but maybe not, because it does seem to work very well, and we can see that in our print. Alright, so we printed a couple more color models, and these took a little while to print. I don't know how long, like 11 hours or something, and this was about 8 or 9. So color printing does take a little longer because of the color changes. I don't know if you guys can see, but there's quite a bit of purge here on the side, but I'm pretty excited to see how these turned out. So let's start with this rook here. So this was printed in blue and gold, and there is an outside shell here we need to break. Not sure how this is going to come off. More complicated shape, so we might have to cut some of these pieces off. Definitely some cutting required. So it looks like our little border here kind of interfered with the print itself, unfortunately. And a little bit hard to clean out on this one here because it went inside it. But it's cleaning up okay. So it seems like the little border that it prints around the print ends up touching the model itself and gets stuck to it. So it's not the nozzles, you know, leaking into the print. It's the outer wall, I guess, somehow being too close to the model. But just pulling it off, this is what it looks like, and it's really nice. So the blue parts of the whole print turned out perfect, but the gold parts, unfortunately, there we had some under extrusion pretty bad right here. So it's not too noticeable, but it is there. And everything is gold inside. I can see the little strand there is under extruded pretty badly in some areas. So I have a feeling what happened here was our filament was jamming in the extruder. That was because of the filament detectors. Because the filament comes from the top and goes into the filament detector, just like I thought from the beginning, the plastic pieces, they wear in pretty quick, and then it starts to snag on the filament, and so it's not able to push it through, and that causes under extrusions. So that's a little bit unfortunate. Can be fixed with either relocating the spool holders or maybe modifying the metal insert where it doesn't cause a drag and snag on the filament. But as far as the transition between the colors, the blue and the gold, and this is a really hard thing to do precisely, this printer does an excellent job. It really looks good. And that's not even meticulously cleaning some of this really fine stringing off. And I have a feeling if it wasn't for the under extrusion, it will look even better. But yeah, pretty highly impressed with this printer when it comes to the dual color. With just a little bit of fine tuning, this thing really does an excellent job. So let's see how our little astronaut comes out. So this was gold with white. Yeah, I wonder if there's an option to not do this little thin wall around the model. Because it seems like the way this printer prints, it doesn't really need this anyway. So again, the little thin wall kind of stuck to some pieces of the model. Alright, and this is what it looks like right out of the shell. So yeah, pretty impressive if you ask me. Now it's not perfect obviously, and the gold has some flaking here and there. But to be honest, it'll clean out very nice and actually look really good. This printer really puts the layers down really well. So we definitely do have some cooling problems. We can see here on his hands, they're quite rough underneath. So cooling needs to be addressed, it appears to be, at least on mine. But again, the color transition between the two colors is pretty much excellent, I would say. It's quite surprising how well this printer does for the multicolor. Now again, here we had a little bit of under extrusion right on the top. I do believe that is because of the filament detectors. But yeah, overall, I'm quite impressed. And I think that if you've ever printed dual color, you would be too, because it's quite hard to get great results from a budget entry printer that are like this. All right, and these are all the prints that we printed on this printer. And I mostly wanted to concentrate on the dual color because I feel like that's the option that most people will use if you're getting a machine like this. So there are quite other unique things that you could do with an independent dual extruder, like multi-material combinations and things like duplication, printing two different models with the two extruders on the same bed, and also using dissolver filaments to print supports could also work great with a printer like this. The included webcam right here, I did not care for it, to be honest. I normally don't like connecting my printers to the internet for obvious reasons, but they did include some nice instructions if you wanted to do that and use the camera and the Wi-Fi options. So we've looked through most of these models, but I did print a few more after that, and one of those was this bearing here. And the reason I really like printing this bearing is because it gives us a test, and so this has to have good tolerances in order to spin, and this printer did excellent. I mean, it's literally perfect, and there's practically no play in it. Very minor, pretty much perfect in my book. So as far as accuracy is concerned, this printer did an excellent job. So I was happy to see that. Also, there is this 40 by 40 square tube here that was actually on the SD card, and this is 400 millimeters tall. I can not even fit it in the frame here, but it's very tall, and you guys can see maybe how well it did all the way to the top. So there's no waviness or anything weird to the very top. So I was quite impressed with this. This is a pretty good test for this printer to show how well it does with its maximum dimension going up. Now I also did the spaceship in spiralized mode, but I did have a failure. So normally this turns out fine, but unfortunately this one just collapsed. So I'm not sure exactly what happened, but if we look at the spaceship itself and how the layers are sitting, they're actually very nice, and there's pretty minimal vibration overall, and everything looks pretty good. But the issue we were having is the layers were not bonding completely, so I'm not sure if that's something on my end. The higher it went to the top here, the more issue we started having, because none of this was holding. It was flopping around the whole way, but it was still able to finish, which is pretty remarkable in itself. The important part is right here around this G, and here usually we can see a lot of vibrations and ghosting around the print. There is some ghosting obviously, and we saw that in the other prints, but overall around these windows it looks very good. So even though this spaceship was a failure this time around, we are still able to see how well the layers sit in spiralized mode. And the last print I did was this cone, and this is a dual color with red and white. And again guys, I am very impressed of how well it does color, even though this is actually a very simple thing to print just by looking at it, right? Like, there's nothing complicated here. Any printer could do this. You could just stop it and then put another filament in and then continue printing. So yeah, that's definitely possible with any printer, but that's not what's going on here. You can see there's a white line going all the way through. There was dual color constantly being changed back and forth, and you guys can see there's no real defects on this thing at all. And I scaled this cone up quite a bit, so the resolution on it is a little bit choppy because of the scale, but very impressive of how it does color. And that's the whole thing about this printer, guys. If you are interested in a dual color printing and you want the best, at least that I've seen so far, this definitely wins hands down. Even the single extruders with the mixing nozzles and all that stuff, you know, those things are hit and miss. Sometimes they work, sometimes they don't. They get clogged all the time, things like that. But here we have individual nozzle, individual extruders, and as long as everything is tuned right and is operating correctly, we get these results right here, and it's quite impressive. And I know I've said it too many times in this video how impressed I am. That should tell you that I did try multiple dual color printers, and this one so far is the best one yet. So there's a lot of things that this printer does right, like the silent stepper drivers. Those are very nice. This printer is very quiet. It's actually on right now, and all you can hear is a hum. So the noise levels are quite low, and it's not really bothersome to be near it. We've got a large touchscreen display with a pretty straightforward UI, removable build plate that's semi-flexible. So, you know, for larger prints, it could help, but for smaller, it's, you know, pretty useless. So that could be a little bit of an issue, but I didn't find it too difficult to take the models off. Once I fine-tuned the offset, it seemed to just work fine. Another great thing about the function of this printer is that every time it goes to print, it measures the bed. Before it starts to print, it checks the bed. And the reason it has to do that is because these Z-rods here are not tethered on the top or don't have individual limit switches to have a baseline to start from. So it's really dependent on you keeping track that they're always offset correctly. And if they're not somewhat, it does level every time, and so it offsets itself. So to be honest, I feel like this is the biggest weakness of this printer. I feel like they should have tethered it up there because it's not adding too much. I mean, they only need a belt and a couple pulleys and it's tethered. Now, another thing I wasn't too crazy about is these filament detectors in the back. They're both plastic, and because the filament feeds from the top down, it's going to wear them out. And unfortunately, I think that's what it was doing in some of these prints. It was snagging up on it. Now, I'm not sure exactly that's what was happening, but it kind of seemed that to me, and it only makes sense. You know, plastic wears in eventually. The more it rubs, the more it wears in, and then it's going to start snagging. So I wish they would have did something a little different back there, you know, have some kind of metal insert so it'll last much longer before having issues. Now, another huge plus of how this printer does the dual color is these brushes, and more importantly, not the brush itself, but these little tabs around the brush. Every time the nozzle goes over it, it scrapes the filament off. So after it purges, it goes out super clean, and it goes out pretty quick, so it only starts seeping a tiny bit before it gets to the model. And also, it doesn't just go on the level of the model, it actually is a little higher and then lowers down to it. And so that seems like the key to get the perfect color transition between the colors without any kind of leakage into the two different materials. So combination with this system here and the way it does it, it just works, and it works very nicely. So overall, guys, I'd have to say that this is a pretty solid printer. And if you always wanted a dual extruder IDEX printer that does a great job of what it's meant to do, I think this won't disappoint. Now, I feel like you will need to tinker around a bit and modify a few things here and there to get it perfect, but it's such a good starting point. With some minor modifications, this printer can definitely deliver on what most people would want from it. Now, with that said, Weedo is in the process of getting this printer to the market, and so there's going to be a few bugs to work out as they refine it. So if you are interested in this thing, you can back it up early and save quite a bit of money by taking that risk. And you should know that anytime there's a new product coming out to the market, you know, there's going to be some risk involved being the first one to have it, but you do get a very nice discount. So if you're interested in that, I'm going to have some links below. Check it out. And I hope, guys, you enjoyed this video. I know it's a little bit long, and these dual color prints do take quite a bit longer. And if you do appreciate the time to make these videos, then hit that like button. So I do have more printers coming up, so stay tuned for that. And if you're interested in more printing videos, check out my playlist. I got quite a few videos in there. All right, guys, well, thanks for watching, and I hope to see you on the next one. Peace.